There is an animal in the Florida Everglades right now that has no natural predators. Can eat a full-grown deer in a single meal, produces up to 100 eggs in a single breeding cycle, is effectively invisible against the wetland vegetation it hunts through, and has already driven several mammal species in its territory to the edge of local extinction. It isn't a prehistoric throwback. It's an introduced pet, and despite years of professional hunting contracts, aerial surveys, trained detection dogs, public competitions, and millions of dollars in federal and state funding, wildlife managers have not come close to stopping it. By the best available estimates, somewhere between 100,000 and 300,000 Burmese pythons are currently living and breeding in the greater Everglades ecosystem, making it one of the most severe invasive species crises in the history of North American conservation. And the most serious tool researchers have come up with to address it involves dead mice, a common painkiller found in every medicine cabinet in America, and a dilemma so difficult that the people studying it describe it as a biological catch-22 with no clean way out. Understanding why that dilemma is so hard requires understanding how badly the situation has already deteriorated and how it got there in the first place. Burmese pythons are native to Southeast Asia, where they exist as apex predators in their own balanced ecosystems and where they have natural competitors and parasites keeping their populations in check. The first confirmed wild specimen in Florida was caught in 1979, almost certainly an escaped or released pet. Through the 1980s and into the 1990s, the exotic reptile trade brought tens of thousands of young Burmese pythons into American homes as novelty pets, including into South Florida, where the warm subtropical climate happened to be nearly identical to their native range. Young pythons are manageable. Adult Burmese pythons reach lengths of up to 20 feet and weights of more than 200 pounds, easily overpowering most enclosures and most owners. When people discovered their cute juvenile python had grown into something they genuinely could not control, many of them simply released it into the nearest wild area, which, in South Florida, often meant the Everglades. Then came Hurricane Andrew. In August of 1992, the Category 5 storm ripped through southern Florida with winds exceeding 170 miles per hour, causing catastrophic structural damage across the region. Among the buildings it destroyed was a python breeding facility near the Everglades, releasing an unknown number of breeding-age snakes directly into the wetlands in a single event. Those animals joined a population that was already quietly establishing itself across the most remote and least surveyed stretches of the ecosystem. And over the following decades, what had been a scattering of escapees and released pets became a permanent, self-sustaining, and rapidly expanding population. By the time wildlife managers fully grasped the scale of what was happening, the pythons were already breeding faster than any conventional removal effort could catch up with. The ecological damage they've caused since then is almost difficult to process as a set of numbers. A peer-reviewed study published in the Proceedings of the National Academy of Sciences documented mammal population collapses of between 88 and 99% in areas of the Everglades where pythons had become established, comparing animal detection rates from before and after the invasion. Raccoons down by 99% in some zones, opossums down by the same margin, rabbits, white-tailed deer, and various wading bird species showing sharp, sustained declines across large stretches of habitat. To reach 13 feet in length over 5 to 7 years, a single Burmese python needs to consume roughly 1 raccoon, 1 opossum, 4 juvenile alligators, 5 American coots, 6 blue herons, 8 ibises, 10 squirrels, 15 rabbits, 15 wrens, 30 cotton rats, and 72 mice, according to estimates from the South Florida Water Management District. Multiply that consumption rate across even a conservative estimate of the population, and you begin to understand why stretches of the Everglades that once hummed with mammal and bird activity have become eerily, measurably quiet. Larger prey isn't safe either. Burmese pythons have been documented consuming white-tailed deer, which weigh over 100 pounds, by swallowing them whole. There are credible reports of pythons killing and partially consuming American alligators, one of the few animals large enough to eat an adult python in return, making their competition one of the Everglades' strangest ecological standoffs. And the pythons are moving. They have already been found in the Florida Keys. They are documented moving north along canals and through habitat corridors toward the southern edges of Miami-Dade County. The question of whether, given enough time and enough breeding cycles, they could eventually establish themselves throughout the broader southeastern United States is one that wildlife biologists take seriously rather than dismissing. Conventional removal methods have produced real results on paper and almost no meaningful impact in practice. The South Florida Water Management District's Professional Python Contractor Program, which pays hunters an hourly rate plus bonuses for each snake removed based on length, had removed more than 10,000 pythons by late 2024. A number that sounds significant until you remember the population estimate starts at 100,000 and could be triple that. The annual Florida Python Challenge competitions, which draw amateur hunters from across the country and organize 2-week removal events, removed a total of 195 snakes in the 2024 competition. The problem with both approaches isn't the skill or the effort of the people involved. It's simple arithmetic. A single female Burmese python can replace 100 removed individuals in a single breeding season. The snakes are also extraordinarily difficult to find. Their coloration provides near-perfect camouflage against the sawgrass, water, and mud of the Everglades, and thermal imaging, which might seem like an obvious solution, is largely defeated by the fact that pythons are cold-blooded and match the temperature of their surroundings. Detection dogs trained specifically to find pythons by scent have shown remarkable success rates in controlled trials, but scaling dog teams across the vast, largely inaccessible, often flooded terrain of one of the largest wetlands in North America is a logistical challenge that no program has come close to solving. USGS researchers studying python ecology have repeatedly noted that reliable population estimates still cannot be derived because the snakes are simply that difficult to detect consistently, even by scientists with dedicated remote sensing tools, tracking transmitters, and years of field experience specifically focused on finding them. Which brings researchers to the mouse. The idea of using acetaminophen as a lethal tool against invasive snakes didn't originate in Florida, and the mouse bait isn't the only experimental tool currently being tested against the pythons. USGS researchers are also developing and testing a range of other approaches, including pheromone-based traps that lure male snakes during breeding season, environmental DNA sampling to detect python presence in waterways before visual confirmation is possible, and even the potential use of sterile male pythons as a biological suppression tool, releasing males that breed normally but produce no viable offspring, a strategy borrowed from mosquito control programs used across Florida. None of these tools have yet produced population-level results. Each faces versions of the same fundamental problem. The Everglades is roughly 5 million acres of dense, largely inaccessible wetland, much of it covered by vegetation that makes aerial observation nearly impossible, and the pythons are extraordinarily good at using every bit of that cover. The acetaminophen mouse bait program is considered by many researchers to be the most scalable option currently available, specifically because it doesn't require finding the snakes. It only requires getting the bait into the places young snakes already hunt and letting biology do the rest. The idea of using acetaminophen, the common active ingredient in Tylenol and dozens of other over-the-counter pain medications, as a lethal tool against invasive snakes didn't originate in Florida. It was developed and tested and eventually deployed at scale in a different invasive snake crisis on the other side of the Pacific. The island of Guam provides one of the most dramatic and instructive examples of what an invasive snake population can do to an ecosystem when given enough time and no check on its growth. Brown tree snakes, native to Australia and the Admiralty Islands, arrived in Guam sometime shortly after World War II, almost certainly as stowaways in military cargo offloaded at Andersen Air Force Base. The timing of their arrival coincided with the near-simultaneous removal of Guam's native predators, which had been hunted out during the occupation, leaving the snakes with no competition and no enemies in a forest stocked with naive, island-evolved birds that had never developed any fear of ground-level predators. Within 2 decades, the brown tree snake population had exploded into the millions. Within 4 decades, 9 of Guam's 12 native forest bird species had been driven to extinction in the wild. Native lizards were eliminated from most of the island. The snakes climbed power lines and caused thousands of electrical outages per year. And because the birds were gone, the trees those birds pollinated and whose seeds they dispersed began failing to regenerate. A snake had broken an entire island ecosystem, link by link, across roughly 50 years of unchecked expansion. By the 1990s, wildlife managers decided the island's native fauna was too far gone for conventional removal to restore. What Guam needed was a way to collapse the snake population itself, rapidly and at scale. Researchers discovered that brown tree snakes, like many snake species, metabolize acetaminophen extremely poorly, to the point that a relatively small dose, equivalent to a small fraction of a standard human tablet, is reliably lethal to them within hours. The USDA Animal and Plant Health Inspection Service developed a delivery system in which dead mice were fitted with small cardboard streamers and laced with acetaminophen, then dropped from helicopters into Guam's forest canopy. The streamers slowed descent and left the mice suspended in the vegetation where brown tree snakes hunt rather than falling to the ground. Because brown tree snakes are arboreal and hunt birds and lizards in the canopy, the hanging mice positioned the bait precisely in the snake's hunting zone. The program has been running for years on Guam, removing thousands of snakes annually from targeted areas, and it's considered one of the more successful large-scale invasive snake management tools ever deployed anywhere in the world. University of Florida. Researchers confirmed that acetaminophen is equally lethal to Burmese pythons. The mechanism is different from the one affecting some other species, but the outcome is the same. A dose that would do essentially nothing to a human or most mammals causes organ failure in snakes within hours of ingestion. The finding opened the door to asking whether the Guam playbook could be adapted for the Everglades, and for a specific, biologically elegant reason. The answer appears to be yes, at least in principle. Adult Burmese pythons don't eat mice. They're too large, and a mouse represents a metabolically trivial meal for an animal that routinely swallows deer. But juvenile Burmese pythons actively hunt small rodents, and crucially, they climb. Young pythons in the canopy height vegetation of the Everglades are in exactly the same hunting zone where a hanging dead mouse would be positioned. The idea is to target the generation that hasn't yet reached breeding age, killing enough juveniles before they mature to cause a genuine long-term population decline, rather than trying to remove enough adults to keep up with their reproduction rate, which no hunting program has managed to do. The early research is real, documented, and ongoing. Small-scale trials involving aerial bait deployment in the Everglades have been conducted, with researchers studying whether juvenile pythons in treated areas encounter and consume the bait, and what the snake activity rates look like before and after. The results from those early trials are being analyzed. But this is emphatically not yet a large-scale, fully deployed program. The millions of mice released outcome shocked everyone. Framing circulating across dozens of online videos misrepresents where this program actually stands. What exists right now is carefully controlled experimental testing, exactly the kind of cautious, methodical research that has to happen before any toxic baiting program in a complex ecosystem gets expanded to meaningful scale. And the reason that caution is absolutely warranted is the catch-22 at the center of this entire problem, the one that makes the Everglades a fundamentally harder case than Guam ever was. When the acetaminophen mouse drop program began on Guam, the island's native bird population was already largely gone. The biological communities most likely to be harmed by a large-scale toxic baiting effort had already been eliminated by the very snakes the baiting was designed to control. The Guam program was, in a tragic sense, operating in an ecosystem that had already lost most of what it was trying to protect. The Everglades is not Guam. Despite all the damage the pythons have done, the Everglades remains one of the most biodiverse ecosystems in North America, home to 350 bird species, 60 reptile species, 40 mammal species, and dozens of fish. Deploying millions of acetaminophen-laced mice across that ecosystem risks harming a long list of non-target species in ways that could compound the damage the pythons have already done. The most urgent concern is the Florida panther. Fewer than 130 wild Florida panthers currently exist, making it one of the most critically endangered large mammals in the United States. Felines are uniquely sensitive to acetaminophen, lacking the liver enzyme that most other mammals use to break it down. A Florida panther that scavenged or consumed even a small number of baited mice could be killed by a drug available in any gas station. Losing even a handful of panthers to non-target baiting in a population this small would be a serious conservation setback, and losing multiple individuals could push a population already on the edge toward a genuinely critical state. The eastern indigo snake presents a different kind of problem. This native species, already protected under the Endangered Species Act, is one of the few animals in the Everglades that actually preys on young Burmese pythons, making it a natural ally in exactly the control effort researchers are trying to support. Eastern indigo snakes also eat mice. A mass aerial baiting program could kill the one native predator that nature has provided to fight back against the invasion at exactly the moment when its presence matters most. Bald eagles, osprey, and other raptors face secondary poisoning risks if they feed on dead or dying mice that have ingested the bait. Even raccoons and opossums, already reduced to a fraction of their former populations by python predation, would eagerly consume any bait mice they encountered, adding another layer of potential non-target impact. The dilemma, stated plainly, is this. Without a dramatic intervention, the Burmese python population will continue expanding, and the Everglades will continue losing the mammals, birds, and ecological balance that define it. With the most promising large-scale intervention currently available, the ecosystem risks losing the Florida panther, the eastern indigo snake, and possibly breeding generations of the raptors that are still there. Florida's wildlife managers are caught between doing nothing and doing something that might accidentally finish what the pythons started. There are approaches being explored to try to thread that needle. Researchers are studying whether the bait deployment could be confined to specific geographic zones where panther home ranges don't overlap with the highest density python areas, or timed to seasons when particular at-risk species are least likely to be in the baited zones. Others are looking at whether different delivery systems could reduce the probability of bait reaching the ground where terrestrial scavengers would encounter it. Whether any of these refinements can reduce the risk to acceptable levels without also reducing the program's effectiveness to the point where it barely dents the python population is an open and genuinely difficult research question. What's also worth noting is what this crisis says about invasive species management more broadly. The Burmese python problem in Florida started with individual decisions, made by individual pet owners who could no longer manage animals they'd bought as juveniles, and multiplied by one catastrophic storm that nobody predicted would have this particular consequence. The cost of those decisions, accumulated over 4 decades, is now being paid by species that had nothing to do with any of it. The Florida panther, an animal that survived the Ice Age and most of the last 10,000 years of climate and ecological change, is now on the edge of extinction, partly because of a series of events that began in someone's living room in Miami. The eastern indigo snake, which quietly evolved to fill a specific role in the Everglades ecosystem, now faces a future in which the tool designed to fight its greatest threat might inadvertently be the last threat it can't survive. That's the real story behind the mice, not a completed program with a shocking, dramatic outcome already in the books. A research effort still in its early experimental stages, wrestling with one of the hardest questions in applied conservation biology. How do you fight an invader that's destroying an ecosystem without inadvertently destroying what's left of the ecosystem yourself? The people working on this problem don't have a clean answer yet. The mice hanging in the Everglades canopy right now are part of an ongoing, careful, methodical search for one. And every day that search takes is another day that the snakes keep breeding. If stories like this are the kind that actually keep you watching, the real ones, where the stakes are genuinely this high and the answers aren't easy, hit subscribe so the next one finds you. And share this with someone who lives near water and thinks invasive species are someone else's problem.